Hello, this is Postdoc Chronicles week 114. And again, this is a quick one because I'm still cooking my rice right there and we don't want it to be burned. But anyway, before we talk about Postdoc, this game, got me a very recently picked Logica Final Fantasy on the Nintendo 3DS. And so the nice thing about this is this is only released in Japan only, so you actually can't play it on English. But some good folks at GBA Temp actually did a fan translation, full game translation. And I really love Picross, my favorite spin-off of Pokemon is Pokemon Picross, and in fact there are like 15 Picrosses games on the Nintendo 3DS, nine of which is the Picross E series, Picross E1, E2 up to E9, and then some spin-offs like Sanrio Picross, a Picross based on what do you call this Zelda, a Picross based on some Nintendo franchises and so on. And yeah, the very first Picross is on the Game Boy. I played that a while back. Mario Picross and Mario Picross 2 also translated. But Pic Logica, it's very frantic because so you typically Picross is a relaxing game. It's a mental, intellectual game, but very very relaxing. It's basically a Sudoku on steroids. You try to form pictures based on the numerical clues found on the rows and columns. I believe the technical term for the format is a nonogram. And yeah, the very first one was a Mario Picross on the Game Boy. But the nice thing about this is Pic Logica in particular is that it is a hybrid of RPG and Picross. So you have your usual 10 by 10, 15 by 15, 20 by 15 Picrosses where you just solve pictures. And in fact, you do these things and then you do quest or missions attribute or that comes with a particular Picross. For example, finish this Picross within 5 minutes and stuff like that. And then if you can do the mission, you get characters known as memoirs, and these memoirs are basically they will form your party, and then you use them to attack monsters. And then the other half of this game is the RPG part where you have monsters on the field, and then on the top screen, you have a battle screen, the usual turn-based RPG. But at the bottom, you have a 5 by 5 Picross, and then in order to attack, you do Picross. And the way you do it is that, for example, you have 5 characters. So if you successfully finish the Picross on the top row, then the first character will move up, and then he will be attacking first. And then if you finish, let's say, the next line of Picross on the last row, then the character number 5 will go up, and then he will be attacking second, and so on. So the ordering of the attacks is based on how you solve the Picross. And the frantic thing, the tactical thing is that some characters, for example, Bart, he will attack like multiple times if you do his Picross first, or in other words, if he attacks first. Some guys, for example, will have a buff when they attack last, for example, and so you have to make sure that you know your characters well. You know which Picross to solve first. You know which Picross to solve last, and it can be, even though it's just 5 by 5 at the bottom, it can be hectic because sometimes the easiest way to solve it is the third row first, and so on. So it's so much fun. It's very deep, and it's a very long game. But yeah, one of the things also, the hassle for a Mac user like me is that in order to apply the translated patch on the game itself, you have to extract the CIA files, you have to decrypt it yourself, and then you have to rebuild it yourself. And it's a hassle on the Mac because currently on OS Catalina, Wine, the Windows emulator, is not working. I don't want to run any virtual machine on my Mac, so there's that. Fortunately, I was able to discover this thanks to this game. I learned about this application called Crossover that basically allows you to run .exe files directly on your Mac, so you don't have to emulate Windows or stuff like that. So very useful. But yeah, I'm currently very playing this right now, and it's very good. On the postdoc, so let's go first to MUED because in MUED, so like I told you, we have like exclusion plots already. It turned out that I messed up. I produced the exclusion plots so right now I'm doing it again. I'm simulating it like the entire weekend. My laptop has been running, but basically the thing is, my first result was run on a 14 TeV simulation, when in fact the run to data that we'll be on comparing it with is 13 TeV. So again, that's wrong. Okay, and the reason is that's why I mess up. Is it turns out that the Roberto's framework, like at the last step, there's like a template card that would invoke that would edit the existing beam energies. So from the cards that I initially produced them from MadGraph, they were 13 TeV. So I thought like, okay, 13 TeV, then they're fine. But then I didn't know that there's like a step where Roberto's framework is going to edit the energy again, and then it turns out that card or that template for some reason has a 14 TeV. So everything, all the 13 TeVs that I have were being edited to 14 TeV, and then basically it's simulating 14 TeV. And fortunately, actually it was Roberto actually, because of course he made the framework. He actually saw it. He said, Marvin, when I showed him the plots that I did, he said, "Are you sure that you're doing it for 13 TeV? Because if you look at the default template card, it is 14 TeV by default." And told him, "Wow, I didn't know that. Like I thought, when I generated them at 13, that's that." He said, "No, there's like a card that edits them again, and so I have to redo it now." So, but at least, yeah, we have simulations for 14 TeV. I don't know if we're ever gonna use it, but we need the 13 TeV. So I'm doing it right now. So I'm done with Wimpy. Power setting is ongoing, so it should be done. I don't know, maybe middle of this week, and then I'm gonna show the plots again. So there's that. And then for the Maverick top of study. So I focused on it last week because Deepak really wanted the results already, and it's because one of the reasons is there's actually has like a master student. I believe her name is Karyin, who will be performing for us the Revit analysis, the Revit plots that we'll be doing. So I generate the event and then she will do the plot. So last week I was able to generate the event, and then just to make sure that I'm getting sane ones, I tried to plot the delta R distribution of the leptons at the final state, because what we'll be looking at is the lepton jet signature. So just to make sure that they have a small delta R distribution, and of course I found it, the peak, they are collimated, the peak of the delta R distribution is around 0. So that's a good indication that I did a good simulation. So I used like a 1,000 GeV top partner. So it's called a Maverick top in the paper, and then this top Maverick top will decay to the usual standard model top, and then to a dark photon. Okay, and then this dark photon, so it has a lot of decay channels. In the searching Maverick top paper, it could decay into missing energies, or it could decay. So it has like a lot of branches. Sometimes the heavy top, the Maverick top itself, also sometimes decays to the usual SM signatures, but most of these are excluded. So that's why there's a new paper that says maybe it is decaying into something that is also beyond the standard model. So that's why there's this Chimera framework where a heavy top, a Maverick top, decays into a dark photon, another BSM particle, and then this dark photon, again, there are signatures that where it decays into missing energy, but then there are a lot of exclusions for those particular searches. The search that we're gonna look at is when it decays to a lepton pair, in particular E plus E minus, and the reason is that there's a few dark photon searches that deals with this final state topology, and Deepak really likes this because in our group, the Jets group at Wheatwater's Run, we like looking at unusual topologies, and lepton jet is it's a novel topology, at least in an experimental point of view. So I look at the specific benchmark points that produces that makes sure or ensures that the decay of the dark photon is 100% branching ratio into the E plus E minus pair, and it turns out that this particular benchmark point is rather restricted. It's like the mass of the dark photon would have to be zero point 0.1 GeV to 0.2 GeV, but it's fine, because it decays into a very light products, which is E plus E minus, which is just like 0.5 MeV, right? So they're really very light, and so that's why they're boosted, even though you have a relatively small dark photon. The final product is are smaller still, the E plus E minus, so they're gonna be boosted. That's why they're collimated, and we're gonna be looking at that. So on my part, so I'm not gonna be doing the Rivet analysis. So Karyin will be learning how to, it's the stuff I did like in 2018, how to plot stuff in Rivet, how to look at distributions. On my part, I'll be looking at which particular searches could exclude the searches that are already implemented in Checkmate, could exclude the benchmark points that we're looking at. So I'm looking at 1,000 GeV to 2,000 GeV heavy top, and then 0.1 GeV to 0.2 GeV dark photon. So I'm gonna slice it up to like 100, 110, 120, and so on. And I'm gonna scan the parameter space, And I'm gonna also look at Deepak mentioned there's like a CMS search for dark photon. So I'm not sure if this is already implemented in checkmates. It's fairly recent. Deepak said it's this year, so it's probably not yet implemented because the search that I'm still implementing, in checkmate, it's like a 2019 search. So I think we haven't caught up yet to the 2020 searches. So I'm pretty confident that it's not yet there. But yeah, if I have time, it would be nice if I could also implement that search after the S bottom search that I'm currently implementing, which again is also giving me problems in the SRB region. But yeah, that's a story for another day. But anyway, guys, this has been Postdoc Chronicles, week 114. I can smell my rice now. I believe it's well cooked. I'm gonna have my lunch. See you next time, and thanks for watching.